Good morning. Thanks very much for attending. Tonight, this morning, we were having a look at the proposed changes to the allocation to accommodate the RNSS satellite system. And Barry is going to be having a look at how, if the proposals, if they are implemented as proposed, how they're going to affect the 23 SEMS amateur radio band. This morning's presentation has been done by Barry Lewis, G4SJH, John Worsnop, G4BAO, and Dave Crump, G8GKQ. They're doing a review of what might still be possible. But background, John is a chartered engineer and former wage slave, radio amateur, moonbounce, Radcom gigahertz columnist, radio propagation nerd, one or two of us out there. RF PA design, fewer of us out there that can do that. Dave G8 GK gained his license at the age of 14. Within a year he was active on ATV in 70 SEMS, starting with 405 line black and white, but graduated to colour as soon as homebrew designs became available. After university, Dave joined the Royal Air Force as a pilot and continued to construct and operate ATV equipment in all corners of the UK and Germany. He's been a member of the British Amateur TV Club committee for over 15 years and now leads the design team for BRTC's Portsdown Digital Amateur Radio Transceiver project. So we are well placed with technology. Welcome our speakers.
Okay, thank you, Len, and good morning, everybody. Nice to see you this morning. I hope you all had a great time at the gala dinner, and your heads are as fuzzy as mine this morning. So welcome to this session, which is going to open with some information on the regulatory framework and its changes that might come along relating to the 23 centimetre band, and as Len said, the coexistence discussion that we're having with the radio navigation satellite service in that same band. So we've tried to do a little bit more than just sort of bore you to death with the regulatory sort of process and details, but we're going to follow, my talk will follow by John and Dave, who are then going to try and give their interpretation of how they may see these changes being reflected in the way that we can use the band or continue to use the band with our amateur activities. So my part is to give you the background on the regulatory changes, and then John and Dave are going to take over and perhaps give a maybe more pragmatic view on what's happening. I don't know how they may do this. We'll see. It should be interesting. So I have been leading on this topic for the IARU, which is why I've branded the slides with the IARU logo, for over 5 years now, I have to say, since even before the last World Radio Conference in 2019, where this so-called WRC agenda item 9.1 topic B, which is like, I hear this in my sleep now, was defined and this work kicked off. So let's see how we go. So hopefully I can give you some impression of the process, because it's taken a long time. I'm sure many of you thought, how long has this been going on? 5 years, how can it take that long? Show you how how formal the process is that we're engaging in here. Some of the developments that are taking place and how they might affect our band, and also some of the uncertainties that we still have about how the outcome or what the outcome of this activity might be at the World Radio Conference, which is coming up in probably around a month's time, not very long from now. But to wake you up, first of all, a bit of training, right? So first of all, ITUR. Who doesn't know what the ITUR is? Anybody here doesn't know what the ITUR is? No, that's good. Fantastic, fantastic. So ITUR is the radio communications sector of the ITU, which is the United Nations agency of the United Nations. So the processes that they use are very formal, and most of the work that they do between conferences is done in so-called study groups. Some of you may be familiar with that. If you know what the ITUR is, maybe you know what the study groups are, which is good. And those study groups are organized according to sort of a number of different sectors, with the satellite industry, terrestrial services and so on and so forth, scientific services and what have you. And they work by defining resolutions, so they resolve to study things and resolve to do other things as well. It's all done by resolutions and study questions. This is the way they define their work. So radio regulations. Who doesn't know what the radio regulations are? I won't say who's never seen them, because no one's going to read them, quite frankly. Every day, of course. Of course. I know some people who read them, actually. You laugh, right? But yeah, so the radio regulations, 4 volumes, and they are published by the ITUR, and this is where everything to do with how radio spectrum is used on an international basis is defined. So the frequency allocations to all the services, and these are high-level services, so you won't see kind of like mobile phone companies in the listing, but you'll see mobile service as a generic service. Mobile service, fixed satellite service, radio navigation satellite service, amateur satellite service. All of these things are defined in the radio regulations. The frequency allocations, as I say, are in there, and all the other conditions that may be required for these different services to coexist are defined, including things like coordination procedures and so on. All this is in the radio regulations, like the Bible of international use of the radio spectrum. International use is the important element here. And finally, the World Radio Conference, which we've heard is going to take place, the WRC 23 is going to take place in about a month's time. Finally, it's scheduled every 4 years or so, and in between the conferences you have the study period that we talked about at the top there, where the study groups do the work on whatever they've resolved to study in the resolution that comes out of the WRC. And the WRC is the only body that has the authority to update the radio regulations. So there's no other process to update the radio regulations. It's all carried out by the conference. So the agenda is set like 4 years ahead, what issues need to be dealt with and tackled and studied, and then the solutions are all brought to the World Radio Conference, and there can be numerous options for different solutions, so-called methods. They use it for solving the issue in the radio regulations, and then they will debate this in the conference and agree in what way they should amend the radio regulations. At the end of the conference, they have so-called final acts of the conference, and that will then be signed up to by all the countries in the world. It's a kind of a treaty, and then that will go forward and be used to actually amend the radio regulations themselves in sort of longer time, sort of 3 or 4 months or so after the conference. Probably be available around May 2024 when the next version come out following the conference. It's a very formal process. Right, so how does this affect the 23 SEMS issue? So as I said, agenda item 9.1 topic B, it'll be drilled into your heads as well as mine soon. It was proposed and agreed at WRC 19, as we heard just now, and there's a resolution 774 is the one that lays out and was agreed at the WRC 23 and lays out the background to the issue and invites the studies. They have these specific language that they use in these kind of documents. So if we look at the text on the left-hand side, it may be a little bit small for you guys at the back, but basically the agenda item was first of all to review the amateur service and the amateur satellite service allocations in the frequency band 1240 to 1300, 23 SEMS to us, to determine if additional measures are required to ensure protection of the radio navigation satellite space-to-Earth service operating in the same band, in accordance with this resolution 774. And then they broke that down into a number of elements which they resolved to invite the ITUR to study. And again, this is the kind of formal language they use. First of all, to do a detailed review of all the different systems and applications that the amateur and amateur satellite services use in the band. So how do we use the band? And then taking into account all those, that review, to then use those that information to carry out studies on whether anything extra is needed to ensure that these radio navigation satellite service receivers are protected from emissions in the amateur and amateur satellite services. without considering removal of these amateur satellite service. I'm going to say amateur services, because amateur satellite services, sorry. So the amateur services, without removal of these amateur services from the band. So any discussion about removing the amateurs is out of the scope, as is any discussion about new frequencies or anything outside of the band 1240 to 1300. You'll just be said out of scope if you try and bring this kind of topic up. So very sort of clearly defined in the resolution, and then they have to develop a process to try and tackle this work, and we'll come back to that in a minute. Let's just look a little bit more at what exactly is the problem for the amateur services in this area. First of all, there's a regulatory problem for us, and that is that the amateur services are allocated on a secondary basis in the radio regulations. You have primary services, or you have allocations given to services on a primary basis or on a secondary basis. So if you're a secondary service, it means that you are duty bound, or you have a responsibility not to cause interference to a primary service. And there can be several of them, of course. We know that in 23 cents we have radio location, radar systems. We know that already. We see that on our receivers. We know we have to coordinate with them at the minute to if we want to put in a new TV repeater or something like that in the band. So they're a primary service also in the band. So as a secondary service, we have to ensure that we're not allowed to cause harmful interference to primary services, nor can we claim protection from those services. So if we see interference from a radio navigation satellite system or radar or other primary service, we can't complain, we have to kind of live with it. So the amateur satellite service is also allocated on a secondary basis, but actually identified by a footnote in the radio regulations. Now, some people have tried to use this to say that even the amateur satellite service is even like lower status than secondary. Some people would try to argue this, but this is not really strictly true. It's quite clear in the footnote that it's allocated on a secondary basis, along with a number of other frequency bands for amateur satellite service. So we have this kind of regulatory issue between the primary and secondary services. We're obliged to not cause interference to the radio navigation satellite service who are primary across this band. And unfortunately, they have observed some in-country interference events. Only two, I have to say, which is strange, but there we are. But both in Europe, actually, and both specifically to the Galileo system. And we'll look at where that's operating in the band in a minute. So they've had some, so these kind of events have really kind of triggered this whole process, and it's made the RNSS people a little bit nervous because they say, hey, amateurs, they can be anywhere, any place. How are we going to deal with this? So yeah, that's why this is kicked off. So that's the problem. Oops, too far. So what is the path for this work? I have showed this slide before, one of the previous events. So starting on the left-hand side, the gender item was defined at the World Radio Conference 19. Then they have a thing called the CPM, which is the conference preparatory meeting, and this is where they start to identify who will do the work that those gender items imply within the framework of the study groups. So for our particular issue here with this 9.1b topic, there were two working parties involved. Working Party 5A, which deals with pretty much all the terrestrial services, fixed, mobile, and amateur services, was the so-called responsible group. So they were kind of, if you like, the lead group on this issue to deal with this. But because it involves the radio navigation satellite service, these guys are in Working Party or Study Group 4, in particular Working Party 4C, where any issues associated with the radio navigation satellite service and other things are dealt with. So there's a kind of a need for the two working parties to work together. So there's a kind of a liaison process, which I try to indicate with the arrow on the left there. So basically, these guys did the studies. After Working Party 5A did the review of all the amateur applications, and there's a report that I'll come to later. And then these guys did the studies, and then back to 5A, started to decide how to resolve the issue. So out of Working Party 4C, we have a report M2513 is now published, which details the studies that they carried out in that study period to, taking on board the information from Working Party 5 on the applications and things we'd have in the band. So we gave them lots of information about the band plans, TV activities, satellite activities, weak signal working, EME, they loved EME, and all those kind of elements of how we use the band. And that was in this report. That is in this report, which is called Amateur Characteristics. For short, they have a shorthand name before they finally publish them. So that was completed, and in fact, it's only just been approved actually in the last few weeks. So that is complete. And then the Working Party 5 decided that, well, maybe the way forward for this work is to somehow develop a recommendation which can provide guidance to administrations on any measures that they think they may need to bring into play to protect the radio navigation satellite service if they want to operate also amateur services in their territory. And this is called amateur_guidance. It's a shorthand name. There's a question mark against this at the moment, and you'll see why in a minute. And the point of this agenda item is that this work, this activity, is fed into what is called the ITUR Director's Report, which is a very specific element of the World Radio Conference. I won't go into that in too much detail because actually I'm not too sure of it myself. But basically, he would report to say that, okay, we looked at this topic, this issue, the study groups did the studies, we did a review, there's a report, and there's a recommendation, and everything is lovely, right? It's all fine. So we've solved the issue. So it goes to reports to WRC 23. This is what was done. There's also another report that comes from the Responsible Working Party to the conference preparatory meeting number 2, where they have developed this huge report, which also goes into the World Radio Conference on all the agenda items, which details the kind of ideas and methods and proposals and studies and everything that has gone on for all the activities. So it's kind of a parallel thing here. But really, this is what should happen. The director would just report, we did the studies, we did the review, here's a recommendation, we think we've done the job, you can suppress the resolution, end of story. Fingers crossed, right? Fingers crossed. So that's the way it goes. So if we look again at a bit more detail of the problem that we're facing, you've probably seen this slide before. I think actually there's even a picture of it on the UK microwave group stand actually. And it just tries to show where we are in the wider context of the radio navigation satellite service bands. They organise themselves into all these different bands depending on the system, L1, E1, G1, etc., depending on whether a GPS system, GLONASS system, Galileo, or some other Galileo system here, which is outside our band anyway. So it doesn't actually have the Chinese system on this chart actually, but GPS of course is US, let's say, driven. GLONASS is a Russian Federation system, Galileo, European Commission system, and the one that's not here is, well, I don't know if it's called Beidou or Compass. They seem to interchange the names, but it's a Chinese system, but we will see where that is in a moment. So you can see the main protagonists for us are the E6 band, which is a Galileo band, and in this band they're developing new so-called high accuracy positioning services. This is their ambition, and they want to make this kind of it's a commercial proposition. This is our understanding of how they want to use it. So they're attaching a lot of importance to this. I mean, you can already receive some Galileo on your smartphone. If you've got one of these GPS apps, you can select the satellite system. You can see Galileo satellites, but it probably is not. It's most likely not this band. It's probably the E5 band or maybe E1 band that's being received in that case. So it's still coming online. The E6 band for them is still something that is not yet fully rolled out, but coming online. Unfortunately for us, you can see it sits right across the middle. This is our band. This is our 23 centimeter band, and bang, it's right there in the middle of our band. We zoom in on that chunk. This is my famous picture. It's been all over the place now. We can zoom in on that 30 on the 23 centimeter band. So we see the three systems here: the Galileo block, which goes from these frequencies you can see on the top of the screen there. QZSS actually is a Japanese system, but it's really a national system actually for Japan. So it's not global to the same extent that Galileo might be, or GPS or whatever. Then we see the Chinese system, compass here, and on the left there, the GLONASS block, which actually extends outside of our 23 centimeter band. And then this is the sort of relationship to the kind of band plans that we use in the amateur service. This is not a detailed band plan, of course, but a kind of a higher level band plan showing where we have, narrow band, medium bandwidth, ATV stuff, and so on, in relation to these systems. So you can see, unfortunately, Galileo is like virtually 40 megahertz wide, and they have a big spectrum kind of emission that occupies pretty much the whole band. In fact, they have two signals in this band. They have one which has a kind of I haven't got a picture of it, a kind of a center on 1278, and then the second signal has two peaks either side, so probably a different chip rate or something. I'm not sure exactly, I can't remember now. So actually they have two signals, so they do occupy a lot of the band. And then we have the Chinese system, which is more of a kind of FDMA type system, if I remember correctly. And then GLONASS has a bit of a mix between FDMA technology and spread spectrum signals as well. And unfortunately, the Russian Federation also have some legacy equipment that extends a little bit further this way. If you look into the report, there is a note that goes to this picture that says that they extend, I think, up to about here somewhere, with some old legacy equipment as well, as they keep reminding us in the meetings. So yeah. So again, I'm just trying to give you an impression of the scale of the problem that we have from our perspective. If we've got to avoid causing interference across this to the receivers, which are wide open across this 40 megahertz band, and we're co-located, we're co-frequency. I mean, it's very easy to do a study that says, hey, there's a problem. Yeah, because we're in band, right? So there we are. How we got to that situation is another story. But anyway. What else? So where are we with this right now in October 23? Because the study period is now complete. Because, as I said, the WRC is only 1 month away. So there are no more study groups or working party meetings to work on this at all. And as I said earlier, we have the deliverables, we have the studies, which is actually complete and published. Actually, we already proposed a revision to that study report, actually. IARU actually made a contribution to the last Working Party 4C meeting, and there is material which is waiting to be put into that report as a revision 1. It won't get done, unfortunately, until next year sometime, but you can access that material, and the WRC can access that material as well. So we make sure that people know where to find that, which is for us an important part of the study, because I think I talked about this at the RAL roundtable. We did the study to try and show the small percentage of receivers that would actually be affected. I see Dave's nodding, so you may recall that, yeah. So that we got that accepted after a lot of heated discussion in the Working Party 4C, and that will be an element that will come into the study. It's just a shame it's a little bit late, really, but there you go. These things happen. CPM report was done a long time ago, which describes the issues and the study outcomes as they were some time ago, probably over a year ago, and the need for measures. Yes, we need measures because clearly you can show there's a problem, and the development of a guidance recommendation. As I said, this recommendation was seen as the vehicle really to, ITUR publishes reports or recommendations, basically, and it could be just a report, but then a report doesn't really tell or provide administrations advice on what they might do. So the recommendation is kind of a guidance. It will say, administrations are recommended to consider the measures given in the annex, and then you'll see the annex describes what kind of technical elements can be considered. So this was seen as the best way forward, the best vehicle for delivering the outcome of this work. The Working Party 5A finalised the report addressing the review, as I said earlier, That was actually adopted at the study group meeting, which is the next level up, just a few weeks ago, 2 weeks ago, something like that. I don't know the number yet of the report. I'm not sure if it's got a number yet, but it will have very soon. However, this is where we start to hit the problems. However, the same working party could not finalize the recommendation. We tried very, very hard to get this recommendation finalized. And from our perspective, it has both sort of regulatory kind of recommendations and technical recommendations. And we'll look at some of those in a minute. On the technical side, I think by and large, we could be reasonably content with some or most of the elements that have been discussed. I mean, we've had to compromise. Everyone's had to compromise a little bit, except for one party, that I'll come to in a minute, who decided that actually none of this gave any protection at all to the radio navigation satellite service, and it should never go forward, and it needs further study and so on. And I'll talk about that a bit more in a minute. So, despite the fact that we spent an extra week in Geneva, working on this recommendation, we could not reach a consensus. We tried to send the work up to the next level because there are no more study group meetings, to the parents, no more working party meetings, sorry. So we sent it up to the next level, the study group, to explain the situation and see if we could get a resolution to the problem in that study group. Nope, that didn't work either. So at the minute, we still don't have this recommendation, which is not a good situation, I have to say. Not a good situation. So I think I've got a bit more detail on why that is. So yeah, so the recommendation itself. So the measures, I call them measures because this is kind of ITU language, technical and operational measures. So the intention was to try and identify parts of the band. Thinking about that picture where we showed all the RNSS systems, there were some small gaps in the band where they weren't overlapping with our activities. Very small, I have to say, unfortunately. So the idea was to try and find where in the band could we operate and in a way that could allow, our applications to be viable best we could and provide a degree of protection to the RNSS, or at least where, if there was interference, it might be more tolerable. And you can imagine that the system band edges are very attractive for this. You can imagine receivers starting to roll off. There was some evidence of this. Some measurements carried out by Germany showed that the sensitivity to interference at the edges of the band was reduced compared to any signals at the middle. They also found that the wideband signals were more troublesome than the narrowband signals. Actually, you can imagine that might be the case if you think about this spread spectrum kind of technique that they're using. And so some point in the frequency band where we could operate with a lower potential to cause interference problems, and some maybe guidance on sort of power levels that might be tolerable as well in these blocks. So this is the way it's been going, and we've spent, I don't know, maybe 2 years or so trying to get some agreement on this. We'll see in a minute. And actually, we have some pretty good agreement, I think, on the upper part of the band. We'll see this in a minute. But we had a lot of discussion trying to find a space for DATV. I'm sorry, Dave, but you gave us the problems. Because of this issue with a broader band signal being more disruptive, shall I say, to the system, and trying to find a space big enough in the band where you could reasonably accommodate this kind of that kind of activity. So why couldn't we achieve consensus on this recommendation, no matter how hard we tried? Well, first of all, the GLONASS system operator, Russian Federation, operator insists that airborne radio navigation satellite service receivers should be fully protected. And it's true that there are airborne receivers in the band. They're identified in the ITUR documentation. So, of course, they are, let's say, within the scope of the study. Airborne is considered terrestrial. It's not like spaceborne. So yes, it's true they are within the scope of the studies, and you can imagine that if you have an airborne system, you can see that from a long way away. You know, if it's a 10 kilometers, 10 kilometers altitude, it's going to be visible from a long distance. So you can imagine the distances that they were talking about were huge to protect those receivers. And insistence that airborne receivers are taken into account leads to such stringent power limits because of this challenge with the coexistence environment that really no amateur service operation would be viable. You'll see on the slides in a minute that the power levels they're proposing are so tiny, it's like a spurious emission level. I mean, it's nothing. So this is, this clearly could not be acceptable. And as well as being not accepted to us, other administrations could see that this would never be acceptable because this, in effect, is removing the allocation. So, some common sense prevails sometimes, should we say. Also, the same operator, the Russian Federation, are concerned about regulatory ambiguity. And what I mean by this is we mentioned earlier about the secondary and primary services and the fact that the secondary service is obliged to not cause interference to the primary service. The Russian Federation say, well, if we have this recommendation and it's agreed, then by default we've agreed to it also because the ITU has agreed it. And then they said, but if we find we have some interference issue some way down the road, what do we do? If we go to that country and say, well, you're interfering with our airborne RNSS, and they say, well, we're operating in accordance with this ITUR recommendation that you all agreed to, they go, yeah, but this is secondary service, so it shouldn't cause any interference. You can see there's a kind of clash here. So it's a kind of valid point, but there's been a lot of stress to say that the recommendation, or stress made on the point that the recommendation does not change that status, does not change that status. There's still, the overriding status is that secondary status prevails and there should not be, you should not cause interference, but this is not enough for them. They still worry about this. Thirdly, they couldn't find any measures in the draft recommendation that actually protect RNSS. I mean, come on, guys, give us a break. So this was when the draft document was shared with the other working party that I showed, the working party 4C, who are the RNSS guys, because we had this kind of ongoing liaison between the two working parties. And they looked at it and they said, well, we see what you're doing. You're pushing things to the edge of the band. You're recommending power levels, but hey, this doesn't protect any RNSS. We don't see how this protects anything. So they actually sent back a note to Working Party 5A to say, we see nothing in this recommendation that protects RNSS. Working Party 5A said, well, tough. What do you want us to do about it? Throw it all away, start again. So it was a really, frustrating, I have to say, situation because, we want to get this thing done. We are finding solutions and compromises that we can live with, and yet we're coming up against these kind of issues. And the final element that caused the problem in trying to find consensus was actually not the Russian Federation this time, but the regional organisation, CPT region, the European region, wants to actually mandate the measures in the recommendation rather than leaving it as a recommendation. And they can do this, or it can be done, in the radio regulations by so-called incorporation by reference. So it means that in the radio regulations, against the allocation, you'll have a footnote that says, administrations shall take into account the measures of recommendation M dot whatever it becomes, the number, so it becomes a mandatory measure for all administrations to have to consider or implement, I should say, not just consider. And clearly this is not something we want because we don't believe that that's proportionate to the problem. But there are also a number of other regional organizations who don't want this either. In particular, Region 2, which is the Americas, they say, no, this is just a recommendation. Region 3, which is the Asia-Pacific region, they don't want any mandatory measure either. From the IOU perspective, we say we don't see any need for any regulatory change, meaning any change in the radio regulations. But CPT which is the 47 countries of the CPT, wants to mandate the measures. This has been driven by, let me say, European Commission, really, who, of course, are the, let's say, sponsors of the Galileo system. And they can, in the process, they can kind of force the CEPT, which is wider than the EU, to adopt this position. So the European common position going into the conference is that they want to see incorporation by reference of the recommendation, or if there's no recommendation, they propose to have a fallback, which is to have a renewed resolution, which is another way to deal with it, where the WRC would resolve to put in place these measures for the amateur and amateur satellite services in this band. So there's kind of two prongs that they can. We don't support that either, of course, and nor do the other bodies that also don't support making these measures mandatory. So the problem with this was it leads to a problem in the language. This is the thing. So what happens is that every occasion, this party here would try to remove any text in the recommendation that proposed it as guidance, as non-mandatory guidance, as something that the administration could consider amongst other measures they might want to take, all this kind of language that they use in these recommendations. So every time they tried to remove that kind of aspect, those parties like Region 2, Region 3 said, no, this has got to be guidance, it must be there. So we couldn't resolve it. So yeah, entrenched views. So that's why we couldn't achieve consensus. Very frustrating, because we certainly need this recommendation. I think you can see, I've already hinted that there could be another resolution. There are other dangers involved in not having this recommendation, actually. So what are these measures? Wow, and what couldn't we kind of agree? So the other frustrating thing about that last meeting was that we went in really with kind of one draft, which was moving in a direction, and it sort of exploded into three alternatives, which is, somehow it all went the wrong way, which is a bit unfortunate. So there are three alternatives in the document at the minute. This is the first one, which was fully reviewed in the working group based on the contributions that came into the meeting from IRU, from China, from France, from most of the parties involved in the process. And I think you've seen some of these elements before. So we have 1240 to 1300 megahertz here on this baseline here. We have the three RNSS systems here, GLONASS, Galileo and Compass systems here, sort of overlaid underneath. And then these blocks, it's not shown as a picture in the recommendation, it's all in text, but this is a kind of pictorial representation of the text. These blocks where we think that we can operate, and the RNSS people think we can operate without causing too much bother for them. So first of all, 1296 to 1300. We have, possibility to have our narrowband applications in there, and some power levels. 50 watts in this block was agreed. 150 watts was agreed for this block here, plus a provision for some EME activity as well, but all narrowband. When I say narrowband and wideband, the protection criteria for the RNSS were defined in two ways, with narrowband interferer and a wideband interferer. Narrowband interferer was anything under 150 kilohertz, and the wideband interferer was anything above 1 megahertz. In fact, there's a kind of grey area in between, so we sort of fudge that a bit, because it's for further study, and we don't have time to do further studies on that. So basically, we can sort of accommodate most of our narrowband activities here somehow. We tried very hard to maintain this part as well at 150 watts, but you can see this is really starting to spread into the Galileo system. So we got a lot of resistance to that, but in the end, we kind of compromised and we got something here, which was better than what we had previously, which was nothing. Everything just moved 2 megahertz up. So we tried to maintain that. Then in the middle of the band, as we go down, we see the amateur satellite portion. is in the radio regulations 1260 to 1270 megahertz. It's 10 megahertz, but you can see this spreads right up into Galileo and also into the Chinese compass system here. So in the end, we tried as best we could to push it to the bottom end of the band. We have 2 megahertz of recommended spectrum there, which I think is reasonable. I think we've sort of corresponded a bit with the satellite guys, and they seem reasonably happy with that. We got an EIRP limit here, which we couldn't avoid. We avoided that here, by the way. An EIRP limit, but seems reasonable, I think, for the type of operation that I think you guys expect to see on 23 SEMS in this part of the band. So that's kind of okay. And then we had the broadband, let me call it that, block 1256 to 1259. We've got a maximum value of, again, we've got some EIRP values here. We had a lot of trouble trying to fight against this and against this spectral density idea. But it seems probably more workable for things like DATV than it would be for our narrowband applications here, where it's just, if you start talking about spectral density as some kind of constraint, it can very easily be misinterpreted in terms of what that means for actually what power level do you use. Because we said, keep it simple. We just want to measure power out the back of a transmitter port, nothing more complicated than that. But some people like this idea of an EIRP, and they like the idea of the spectral density. But if you work it out, it means that you can have 50 watts per 2 megahertz for broadband applications there, and for narrowband as well, also 50 watts for 12.5 for a 12.5 kilohertz system there, which I think is probably okay for the kind of broadband activities that we see. Then nothing below that. And then for all these parts outside of the band, there is a ridiculously low power level of actually 5 milliwatts proposed, which is basically off, right? So, yeah, we tried to push for a bit more. We tried to push for half of what we said. Well, how can we measure 5 milliwatts? No one can measure this. You put a mixer on the table and it's already radiating at 7 milliwatts or something, 10 milliwatts, who knows? But basically, they don't want any emissions in this area here. So it's somehow trying to say, well, we don't want to see any activity here, but we're not removing the allocation. It's this is sort of a wordsmithing thing. But I can tell you, this is not the lowest level proposal. There's worse. So this has got quite good agreement in the working group, apart from those issues that I mentioned on the previous slide. This, as I say, this has been quite stable now for a while, and I think the Galileo guys are, comfortable with this. So we don't like to try and upset this, and even the Russian Federation guys aren't touching this part of the band. So it seems okay. So then we have alternative 2, yay, which is also quite nice actually. This is the same, no change here. This is the same here. Same for the amateur satellite service. So that doesn't change there. The difference is this bit below 1256. So there was a kind of a proposal from France, actually, as you can see, are quite open about that. They're quite open about it, trying to overcome this issue with the regulatory ambiguity for the Russian Federation. They said, okay, well, why not have no recommendation below 1256? So as far as they're concerned, below 1256, it's the same as it is today. Secondary allocation, no extra measures, no ambiguity, everything's fine. They say, well, yeah, but I don't think, we can have this recommendation that only treats some RNSS systems and not others. So you can imagine there's a kind of discussion about this. From our perspective, we quite like this one because, we carry on as we are today, below 1256. So that's also fine for us. By the way, on the last slide, we had 3 megahertz for the DATV for broadband. We tried very hard to have 4. For a long time, we were proposing 4. We had a bit of a head-to-head with the Chinese, and in the end, we had to kind of compromise on 3 because, as we just go back there, just look quickly back. Which way are they going? That way? Yep. No. Sorry, it's right across the middle of their edge of their band there. So we're kind of caught between the Russian Federation and the Chinese, and it's probably not the best place you want to be, right? So Yeah, so we were sort of squeezed a bit. Originally, China proposed just 700 kilohertz. They proposed exactly this gap. I mean, again, it's not viable for us. We have to have something that is viable for our applications. Anyway, so we quite like this alternative too. So this is still on the table. And some parties are even now in the background, shall I say, trying to elevate this possibility. And then we had alternative 3, which is the Russian proposal, pretty much. Doesn't touch this bit, thankfully, at least. But you can see everything else is squashed. I mean, they have, here you can have, here you can have a maximum value of EIRP minus 19 dBW per 150 kilohertz. Right, that's off. And then you can have even more off here, right? Because here you can have, it's actually even lower. I didn't even put the figure on there because it's so silly. I mean, it's even lower EIRP here. And they proposed an elevation mask. It's like, oh, guys, what are you doing? This is not guidance. This is like a full-blown sharing study, about someone bringing in a new allocation. Anyway, we don't like this one. And I think some other parties don't like it either because they feel that because it's so ridiculously low, it is virtually, suppressing the amateur operation in this band. And this is only really supported by the Russian Federation. You can have 14.5 microwatts for 12 kilohertz. Yeah.
Barry, how long has GLONASS been around? It's a long, long time.
Long time, yeah.
And I presume that they don't have folders full of reports of interference.
Absolutely not. Yeah, exactly. We said, as soon as they introduced, we said, and exactly how many cases of interference any of you had? And they said, none. What are we doing? So, yeah. So at the moment, these are the 3 options at the table. Probably, I don't think this one will prevail. I hope not. I can't imagine it will because it's ridiculous. We hope that this one will prevail. The problem was because France proposed it, they didn't have this guidance language in it. So this is what really stopped this moving forward as a consensus. And of course the Russian Federation is saying, well, yeah, we see what you're doing, but we're not sure we want to be somehow excluded from this. Yeah, so these are all on the table. So how does this all fit with the radio regulations that we've mentioned several times? As I said, it can be made mandatory by incorporation by reference, implemented with a footnote, as I said, and there are several administrations, the amateur community, and some regions who are completely opposed to this because we consider it disproportionate. Again, your interference issue. It's the same for the Galileo, only 2 cases. And by the way, 2 national cases of interference, which were cured, except in Italy, because it's Italy, by national action. Job done. Yeah. What do you need all this for? But there you go. Yeah, so people generally some people are opposed to this. If the recommendation fails, this is where we start to have some problems, because we could have this resolution proposed by France, but that resolution would include also some technical elements, otherwise it would have no value. So then you'd end up probably having the same argument about the technical elements in the resolution as you're having in the recommendation. So I can't see how that will pan out. And as I said, so that would be a mandatory measure and also contain a version of those technical measures. Which one? 1, 2, or 3? Hopefully 2, but hopefully not at all. So at the study group 5 plenary, where this was elevated up from the working party where we couldn't agree, the recommendation was not adopted, despite, I can tell you, there was frantic effort in the background trying to find a solution. And there were at least 20 variations of the draft document circulating in an email group over 2 days, and we still could not get a final text that was happy for everyone. So we still don't have a resolution. So that means we have one more chance, a thing called a thing called the Radio Assembly, which happens as a meeting that happens 1 week before the World Radio Conference, and that has, amongst a lot of other things it does, a group that deals with finalising material that's needed for the WRC, things like this recommendation. in principle. But again, we can't be sure how that will pan out. We can't be sure even that they will have time even to discuss this. And so there is still some uncertainty on whether we'll have this, this recommendation. Yeah, so as I say, it leaves the uncertainty on the way forward for WRC. So apart from the resolution proposal from France, there could instead be a proposal, maybe the Russian Federation might be interested to do this, to revise the existing resolution 774, which is all this is being done under, to allow further studies into the next study period. This we really don't want. Really, really we don't want this. You know, there's barely any justification for it, your point again. But there is a danger that they would want to widen the scope, because they have mentioned many times and received pushback on it, that there are other radio navigation satellite systems, not just space to Earth, but also space to space, where satellites communicate with each other in space, and that they can look across, they can look down, so you know, look up. You can see that this would be could be quite challenging if you start to study this. And they have even said the position of the RCC is the Russian Federation's group of countries regional organisation. They've made it quite clear in their position that they intend to propose you know, additional studies. So again, if we don't have this recommendation, then it leaves it kind of open to this discussion. So we really, really would like to not see this happen. So this is what I mean when I talk about, you know, people say to me, well, how's it going? I say, well, you know, it's difficult to characterize. Now we have this extra blob in that picture that we had right at the beginning. We have the radio assembly has come in now. This is another week in Dubai. So the guidance, which is still failed, will go in here. And we know this will come in because I think that we know that France are making a contribution, and also the Region 2 people are making a contribution into this discussion, and that will feed into the WRC. So this is the extra step. So we really, really hope that in this meeting there's a way that it can resolve this lack of consensus on the recommendation and have something that goes forward with one of those measures, hopefully alternative 2. Fingers crossed again. So we're getting towards the end. Summarising the measures, I think you've probably got the idea now. You know, the idea would be that these guidance, these measures that are in the ITU guidance, would eventually, of course, be reflected into national licensing. So there's still further stages before we feel the effect of these kind of measures, and of course we don't yet know how administrations will respond. Some may say, well, we don't care about the protection of RNSS, so just carry on, guys, as you are. Or there are others for whom it's important. So how this pans out is still a little bit sort of uncertain. But you get the idea, the measures, confining our amateur activities to certain parts of the band, with basically the rest of the band, quite a large part of it really not usable in any sensible way, unfortunately. Again, we can continue with the narrowband activities in the top end of the band. Okay, we might have to have some changes, and maybe John and Dave will talk about this a little bit. Broadband, we still find somewhere for broadband TV. Depending on which alternative, we may or may not be able to continue with analog television. I mean, clearly, I think if you have alternative 1 with 3 megahertz, it probably isn't space in the band anymore, really, for amateur TV. Current voice repeater shifts would be unusable, which is unfortunate. We tried very hard to get a block in the middle of that Galileo band, a low power block, to still enable these systems to continue. But this was very, very difficult to argue. Again, you can understand, right in the middle of the spectrum, they were very nervous about that, very difficult to do. But maybe a wider split could be possible, so you know, all is not lost. So if people are really keen on having voice repeaters and things in the band, then there could still be a way forward. I always think, you know, I said to John earlier, well, we're radio amateurs, right? We're flexible, we're innovative, we find ways of doing things, right? So hopefully that. In-band ATV repeaters may not be possible, but actually in the UK we may be better off because we have this extra extension up to 1325, so that may not be completely impossible. And amateur satellite operation is restricted to 2 megahertz of the band. But what I'm hearing is people aren't complaining about that too much, so there we are. Oops, some more measures. So just 36 days to go to the WRC. As I said earlier, the radio assembly has come into the picture, which will a chance to have a final look at this recommendation. So the deliberations may be dependent, and you know, several possibilities still remain. No change to anything in the radio regulations. You know, so just a recommendation, nothing more. Or recommendation incorporated by reference, which we don't prefer. The WRC resolution to apply the measures if there's no recommendation. Or a new resolution and new studies for WRC 27. Really, we don't want that. As the IARU, we don't support any regulatory change because we think that the whole thing is overblown, quite frankly, with just 2 cases of interference, and we think there are probably, you know, political and commercial pressures trying to make this into an issue that is not quite as bad as people might like to want to think it is. And then meanwhile in Europe, and we're nearly there, there will be a European element to the regulatory changes, probably after the WRC. They will develop their own CPT decision that will probably look more like that alternative 2, because actually in Europe they don't care about GLONASS. CPT doesn't care about GLONASS below 1256, so any regulatory deliverable they come out with can let's say ignore that part of the band. That'll probably continue through next year in the CPT working groups. For the EU countries, the measures could become mandatory because the European Commission can issue a spectrum decision which requires the EU member states to implement the decision in their law. Yeah, which this is something that I think they would clearly, you could imagine that they would try and head in this direction, but we'll see. And the CPT work, which has continued in the background, has really been pretty much overtaken now by the activity in RTOR, but we will come back to it. In fact, tomorrow I have a CPT meeting on the topic. And then, you know, it's not all just me. See, here's the happy band. The happy band of our team in the international groups. As you can see, nice global team from Australia, Japan, the US, Canada, Norway, Germany, me, Brazil, Holland, Netherlands. So yeah, so we've been onto this, and there we have it. That's pretty much the situation. So when people say to me, "Oh, what's happening on 23 cents?" Well, it's quite challenging to put it in a nutshell. Yes, please, this gentleman here, next to Maury, because I know who Maury is. Oh, there's a microphone somewhere, just yeah.
Hi, I'm Mike Naylor, G4CDF. Interested in the 150 watts at the very top of the band. Does that mean that sort of contesting SSB, CW, etc. would move up by a couple of kilohertz, or a couple of megahertz to get that power level? And is that power level measured at the antenna, or is it at the transmitter, please?
Okay, so you're talking about this block. Let's use this one. This is the nicest picture. You're talking about this block here.
Yeah.
Okay, so remember, first of all, these are not license conditions, right?
No.
These are guidance. Okay, so it is clarified, I think, in the recommendation now that it's peak power. What's the way we normally define
peak envelope power?
Peak envelope power.
Yeah.
Thank you. Peak envelope power. We try to avoid discussions about whether is it at the antenna or is it at the transmitter, because we don't want the ITOR to be tying down exactly how this is kind of measured.
But our license allows us to have the transmitter
Well, this
power
is not
measured
your
at the
license.
antenna?
I
No.
mean, that will be for your.
Yeah.
That will be for your. Yeah, that will be
Yeah,
for your national administration to define if they think it's important to define. At the minute, our assumption is this is 150 watts, maybe at the end of the feeder. Right?
Assume the option that suits you best would be my answer to that.
Sorry,
We're not, because again, the important point is that we're not defining the license conditions here. We're trying to just define some guidance, a direction of travel for the administrations to consider, and they can define how they think it should be measured. Yeah. And sorry, there was another element to your question, Mike, wasn't it? Oh, okay. Oh, you talked about moving up, though, didn't you? Yeah, because, and my point there was clearly, at some point, we will have to, as the amateur community, we'll have to think about how it wants to, use this new framework, if it's starting to come in, how we move, how we migrate from where we are today to this situation. I mean, I'd hate to see this part of the band orphaned. In the end, we've fought hard to keep something here, so maybe there's a way we can still make good use of this. Maybe we have to move narrowband activities eventually up into this part of the band. It all depends on how it sort of pans out. But I don't think that's that's not too big an issue, I don't think. Murray had a question.
If you go to the previous slide.
Alternative 1.
Yes.
You sure you want to look at alternative 1?
I have a
Okay.
cunning question.
Cunning question.
So, obviously this has been based on ILU general regional band plan information, okay? If that came back to the UK, is the UK rep aware that the 1256 to 1259 area is the last possible place he would want TV repeater inputs? The most compatible place is where they are today down at 1249, because 1256 is thou shalt not transmit anything because you're in
So
one of the main
just says we
radar
prefer that one.
subbands.
That just says we prefer that one, doesn't it?
Yeah.
Yeah, exactly.
So it's not very the radar situation is very nationally specific in all the countries,
Yeah, I agree.
and it's changing.
We've made this point, Murray,
Yeah.
to say that we don't. It's not just about where we operate in the band. We need flexibility because we have to already coordinate around existing other primary services. But this is when you're getting the pressure from China and from Russian Federation, it's hard to do. But your point about the UK is, I mean, they are present in the meeting. They see what's happening here. They haven't sort of commented. And there are other national issues. I mean, in Italy, they don't have this. Right? This is a bit unfortunate. But I don't see any Italians getting upset in the meeting. So we can't know all the national situations. This is the problem for us. We're trying to get a good solution here. But let's see how it goes. Yeah.
Okay, so we've got 2 more presentations, so if you don't mind, we'll
Of course.
move on. But could I ask you to show your appreciation for Barry's part of the
All right.
presentation?
Thank you.
It's okay, kind of moving on to the second part of the presentation, where John's going to be doing an engineering perspective from the proposals. Thank you.
Right, well, good afternoon. First of all, big thanks to Barry. I have ultimate respect for the work that Barry and his team have done. I wouldn't have the patience. So, what I'm going to look at now is, I'm going to look specifically at EME and DX working in that top 4 megahertz. And I'm just going to look at a few what-ifs if these proposals do become what we have to do and the possible consequences. The current situation on 23 SEM's terrestrial and narrowband DX activity, I'm going to say a few things that people might cringe at, but it's true. It's mainly limited to 1296.1 to 1296.3. That's where the bulk of the activity is now, in this huge band. Most of the activity on the band is during UK AC contests, so once a month for 2 hours. That's where most of the activity is. There is obviously activity in between, especially when conditions are good, but it's mainly on during the contests. The centre of activity is still historically around 1296.2. There's some FT8 operation on 174. there's no significant DX activity anywhere in Europe above about 1296.4. Most people are squeezed into that bottom 200 kilohertz, simply because you will, like FT8, you will go where the activity is. So the activity is around there. So most people's systems who have optimized their DX systems are optimized to work around 1296.2. So antennas are tuned to that. They get the maximum power out of their amplifiers on that sort of frequency. And we have the lovely 400 watt PEP and no antenna restrictions. So we can run lots and lots of power on this band. And to get good results, you do really need a lot of power. Need, but not always have. On EME, again, most of the activity is on digimodes, Q65, and that's around 050 to 150, so it's in the lower portion of the band. There's some CW, and there's a lot of CW during, especially during the Dubas contests, and that's mainly in the bottom 50 kilohertz. So EME, you're talking about the real bottom bit up to 150. Most of the terrestrial is from there upwards. You go on in a contest, you won't hear too many people above 400. So that's where we are currently. And there's no significant EME activity above about 1296.2. Again, simply because people go to where the activity is. They will cluster around one frequency. And for EME, most people optimize their systems a little bit lower down, about 1296.100. So we're talking about most systems are set up now for the bottom section of the 1296 band. Again, 400 watts PEP for EME. There are some kilowatt permits out there. I don't know anybody who's got one, but there are some people who can run a kilowatt on 23 and do. There are amplifiers around. No antenna restrictions other than the usual UK EMF limitations of don't point it at your neighbours and run through all the tests and the spreadsheets that the RSGB has currently produced for us. So, let's look at, I'll call it a proposed draft recommendation. I couldn't think of any more added words because it's no more than that. It's a proposed draft recommendation. And the thing that sticks out in this top 4 megahertz, there are different sets of rules. I'm looking initially at terrestrial activity. There are different sets of rules for the current band that most people use, 1296 upwards, to this one at 1296.3. The lower section, the rule is looking like a 50 watt restriction on power. That's where we are now in that part of the band. So that's a 9 dB reduction in power. So that's almost a factor of 10. In 1298 to 1300, you've got 150 watt power restriction. So that's a 4.3 dB resolution. So that's a factor of about 3 and a bit. Now, the thing that is your question here, the thing that screams out from this is if this is going to work and everybody's going to move up to this new band, everybody's going to have to move up to that new band. Anybody within dropout range of the UK needs to make that move to make it viable, or else you get into the situation where you're doing cross-band working, and everybody knows what a nightmare that can be. The only thing that springs out of that is some antennas might have bandwidth restrictions going up to 1297 rather than 1295 as a centre. But looking through, I recently did a review of Yargis for the QR100 in my, sorry, Yargis for the IC905 in my column, and a lot of them do actually specify them for the whole 4 megs. I'm not sure I believe that, but I think with some judicious bending of folding dipoles, you could make most modern Yargis cover up into this new part of the band. So there's 2 issues there. There's antennas, and everybody's got to move for it to make it viable. Now, going on to EME, this first slide says we have the same rules as for terrestrial, but there is a rider to that. So once again, 150 watts PEP allowed from 1298 to 1300, 50 watts from 1296 to Oh, sorry, that should say 1296 to 1298. You always spot one thing on the slide. And again, the good thing about this, no restrictions on antenna size or elevation, and the UK EMF limits the only restriction in a first look at EME activity for that. But very nicely, they seem to have negotiated a QRO option, which looks good at first. 500 watts PEP from 1298 to 1300, but there is a but attached to this, and I'm going to look in a little bit more detail at what this but actually is. There's two limitations. If you've got, if you want to run 300 watts, no operation at this power below 15 degrees elevation. And at this power, and when I first read this, I went, what? You have to have an antenna that's greater than 13 dBi. So if you're going to run high power, you have to have a higher gain antenna. Okay, I thought about this for a while, and I talked to Barry, and I said, what's all this about? Well, it's basically about, it's a compromise. Obviously, the higher gain antenna you get, the smaller your side lobes are. So this is an attempt to keep the side lobe, if you're beaming at 15 degrees elevation, this is an attempt to keep any side lobes from your antenna coming out horizontally. But Barry pointed out to me, I won't use the word kludge, but it's a bit of a compromise, just so that they can, I mean, correct me if I'm wrong, but seem to be doing something that's trying to mitigate this problem of high power pointing at the horizon. So, all right, and again, of course, all the UK EMF limitations remain. So, that's what we're saying, 30 dBi gain antenna. So, I'll come back to EMA in a minute, but I'll move on first to terrestrial operation. My favourite photograph of my antennas from a few years back, you must have seen this everywhere, I've used it endlessly. I've come up with, which I've put in inverted commas, a DX-capable terrestrial system. And it's stuff you can buy off the shelf. For 9,700, a Wemo 44-element Yagi, a Gemini PA that'll give you, when I reviewed it, it would comfortably do 200 watts, and 15 meters of Ecoflex 15 with 1.7 dB loss. And on a system like that, your masthead power, which is what you were talking about, what's at the end of the coax with that, you'll get about 135 watts out of that. And that is a very capable system for working DX on 23 SEMs. So I'll look at this as an example and go through some of the changes being proposed. First of all, if we stick in 1296 to 1298, and we've got this 50 watt power limitation, that's 4.5, 4.3 dB less EIRP. So how do we win that back? So how do we get back 4.3 dB on this system we had with a single thing? Well, you can do it by upgrading that single 44-element Yagi to two 5.1 meter long 67-element Yagis from Wemo. That is what 4.3 dB means in terms of antenna. That 44-element is about 3 and a bit meters long, so you're nearly doubling the length of it, and you're doubling the number of antennas to get 4 dB back. Or, and it's probably getting more practical, a 1.5 meter dish properly set up with a decent feed will give you that increase in gain over a single Wemo. So that's what we're talking about, to stick where we are and have the same EIRP and have the same transmit performance with this new restriction. So I hope you've all got tolerant neighbours and tolerant wives if we're going to go that approach. I know I have the advantage of having lived in my house for nearly 40 years now, and I was almost the first person there, so everybody just comes and says, oh, but can't really complain. So, if we go to this upper band, think back 2 slides, I said that was 135 watts, that system. That system is perfectly legal under this new system in the new band. In fact, you've got a bit more power. Yeah? you can crank your Gemini up and get it a bit more distorted, and you can get to 150 watts at the antenna. And you might just have to bend the elements on your Wemo or on your Yagi antenna to try and match it. You can move them quite a long way just by moving the element around. So that upper band move for what you might call a sensible system is not actually as bad as it might seem. But everybody's sitting there going, oh yeah, but I run 400 watts. I've got my 700 watt amplifier, and I turn it down, of course, to 400. But all I would say to people like that is, lucky you. It is going to affect, if you're used to running the full legal limit, it is going to have an effect on you. But the alternative to what these guys have done in these proposals is quite stark. And it comes down to one thing, as Barry has been pointing out, with these ridiculously low power restrictions. The alternative is quite stark. A number of countries have already lost the band completely, gone. Yeah, that's a bland statement. And we're no different from anybody else, and not being in the EU is not going to help us. We have to be pragmatic about this, because I was told not to use the term safety of life because it means something particular, but this GPS is a safety-involved systems. But I was told that Murray was going to cringe if I said safety of life, but he's cringed that I said safety. But if you've got this driving a self-driving car,
it's not a safety of life.
Exactly. That's exactly why I didn't put the word safety of life. Sorry, Barry. I have to confess, Barry and I were sniggering about this earlier on, because I initially put safety of life, and he says, you don't want to put that on there, that'll really wind up Murray. And it did.
It's how you lose balance.
Yeah, I know. Yeah. So, going back to this then, if you are used to running 400 watts PEP and a big system, it's, you're going to have to live with it, I'm afraid. So, let's see what else we can do to help just improve. I'm going slightly off at a tangent here, but let's think of some ideas of how we can actually improve things. Lose your feeder loss for a start. It's quite relatively straightforward to mount a 50 watt or 50 volt LD MOS PA, even a high power one, at the masthead. If you've got even on a pole. I've got a lot of heavy transverters and stuff on a 2-inch pole on my gable end, so you don't need a tower to put a 50 watt amp up on the mast. And 150 watt PA probably needs about 6 amps DC. And with your 15 meter run of 3202 wire, you'll probably drop about 2 volts. So if you start at the bottom with 50 volts, you'll have your 48 volts up there. And it's not difficult these days to generate 50 volts when you're out portable. There are some very, very, very efficient switch mode power supplies that will take 12 volts from a LiFi and generate 50 volts to drive a LD MOS amp. So we've got to start thinking out of the box a bit, and we've got to start thinking, well, how can we, if we've got this, how can we do it? So minimize your feeder loss. You can gain yourself your 1.7 dB there, and you can run that 150 watts or whatever it is right at the masthead and no feeder loss. I don't know why anybody is on 23 SEMS without one of these, but it's almost essential to have a masthead mounted LNA, and I just like throwing little figures like this about because it often surprises people. On my previous DX system, I talked to Sam about the 9700 because he did the practical wireless review on it, and he said the noise figure of that is typically 5.5 dB. So if you add feeder losses and everything else, you end up with a noise figure plus a feeder loss of 6.2 dBs on your system with no preamp. If you turn that into minimum detectable signal sensitivity, that's minus 132 dBm. So you get yourself a half dB preamp with 25 dB gain, easy enough to do on 23 SEMS now. Half a dB noise figure on 23 SEMS is not difficult now. Decent filter in it. You end up with a system noise figure of about 0.7 dB. Anything below 1 dB on 23 SEMS is probably okay for terrestrial. What does that do to your sensitivity? You gain about 8 dB with a typical noise, sky noise. I've used a random sky noise of 200 Kelvin, so I've assumed half of it's warm and half of it's sky. So I just picked that figure out. But if you do the sums on that, you can gain 8 dB of system performance on receive with just by fitting a masthead preamp. So there's all sorts of things that you can do to mitigate the issues we've got here and improve your own systems. And this is a point I'm trying to make. This is an opportunity. We can see this as an opportunity to make our systems better within the limitations we've got. So moving on to EME. That's my lovely dish and my flowers. This dish is now in somebody else's back garden. I've moved on from that now and gone to higher bands. But to retain the QR option, to retain this 500 watt option for EME, you're going to have to move to 1298 to 1300. And the whole world's going to have to go with you. That's the difficult bit. Everybody has to agree that EME is going to go above there. But if the alternative is 50, I think that's pretty good. That's great, but there's two restrictions in red. No operation below 15 degrees, and antennas must be greater than 30 dBi. So just to put it in perspective, 30 dBi is a 3-meter dish. Now I haven't got room for a 3-meter dish in my back garden, as you saw from that previous photo. But a lot of people have. And I will probably say that the majority of 23 SEM EME systems run a 3-meter dish or bigger. So we've just got this elevation of the 500 power limit. And in fact, we've got 500 watts now, not 400. Yes, Mary?
Other people will have, you won't.
So, I'm sorry, I'm not with that. I didn't understand that.
This is not a UK license condition.
Yes.
This is...
This is Murray's point. This is...
Yeah. The
Yeah,
UK
well-
license will stick to 400.
Oh, will it? Oh, okay, right, okay. Well, it's not going to be included in that. It isn't going to be included in that kilowatt thing. Okay, well, you can, but it'll stay the same then in that case. Yeah. Okay, I hadn't realised that. I thought we were. I thought with this kilowatt coming, we would fit under there, but no, the power's not really the issue here. The issue is elevation. Let me do a couple of EME examples on elevation. From my QTH in East Anglia to Wellington in New Zealand, at the moment, I've got 18 days a month where I can work a 10-minute moon window to New Zealand. 18 days a month, and that's purely geometry, path geometry, because I took an almost antipodial station. So there's about 18 days a month at the moment I can work down to 0 elevation. I can work New Zealand on EME if I had a big enough dish. I did that calculation recently, and that was quite a surprise. You're never going to work New Zealand above 15-degree elevation. The geometry doesn't allow it. Okay? And when I saw that, I thought, crikey, how does this affect other paths? From my place to Sydney, you can always work Sydney at 0 elevation from East Anglia to the centre of Sydney. You can work that 28 days a month. That drops to 16 when you've got 15 degrees elevation limit. So it's this elevation thing is interesting. How about Alaska? 17 days a month you can work Alaska for more than 10 minutes. That drops to 14 days at 15. So it's not going to remove EME completely, and of course you can work EME with 150 watts, and you can work New Zealand with 150 watts down to 0 elevation, so it's not the end of the world. But if you've got a big dish and high power, and you've got this 15-degree limitation, they're just a couple of examples of what has happened. What about signal strengths? Well, with the moon at apogee and 400 watts, half a dB noise figure and a 3-meter dish, if you do the calculations on the wonderful VK3UM calculator, it says you will get a minus 9.1 dB echo in 2.5 kilohertz according to VK3UM. And that's about 2.5 dB better at perigee. That's what the calculator says. You're smiling because I've not seen levels like that on dishes that size, but this is just to give you an idea of the changes. With 150 watts, that echo drops to 14 dB. Okay? So you've got, again, this 4 to 5 dB drop in power. So that's what the 150 watt restriction is going to do with a 3-meter dish. With a 1.5 meter dish, you are struggling you won't work CW with a 1.5 meter dish, but you will work JT modes quite comfortably with 400 watts. You'll get something like a minus 22 dB echo. But if that, with 150 watts, that's down to minus 26. So you're beginning to struggle with some of the JT modes even then at that sort of level. But it's doable, as I'll say. Because I'm going to throw a bit of perspective in here now. In terms of, some of it looks good, some of it looks bad. From my personal view, I made 78 CW EME QSOs with the big guns using between 150 and 200 watts on a 1.9 meter dish. So it's quite possible, if you set the thing up properly. I have something like 122 initials. That's different stations, worked on 23 on mixed modes. I worked on continents before my tree got too big and I can't see Australia anymore. So it is possible. It's not going to be the end of EME, nothing like it, but it may have to be different. And actually, looking through dish size, there's a database of VME operators which is self-provided, so it doesn't cover everybody. But of the 625 stations on that list with 23.7, 78 of them are using dishes smaller than 3 meters or EARGI. That's 12%. But sadly, most of those are the guys who are new to it and they're getting all excited and trying it for the first time and haven't got around to putting up big dishes yet. So that's a shame that they're going to be the worst affected in some ways. And then, and this is the one that makes me cringe a little bit, is there are de-expeditions to think of. Anybody who's been on a de-expedition knows how difficult it might be to take a 3-meter dish on a de-expedition. Some do. There are some folding dishes that are quite big, but most of them you'll find will take a big 500 watt amp, 1.5 meter dishes or even Yargis. I did an operation from the Isle of Lewis a few years back with 150 watts and a single Yargi and worked a few stations. So under these rules, anybody who's taking on a de-expedition would now be limited to 150 watts. And that would not be good for the CW stations who wanted to work them. And it would not be good for the small dish Digimode stations that wanted to work them. So that's another consequence of what might happen. So really to sum all this up, going back to terrestrial, 50 watt stations in that low band, you're just going to have to put bigger antennas to retain the same capability. In the high band, 3 things are off. Everyone's going to have to move to make it work. There's going to be no QRA operation above 150 watts. So changes are only really bad for stations who are currently running more than 150 watts on the band. And for EME, well, some of the Ultra DX paths will be no longer possible due to the elevation restriction, but not impossible, because you just drop to 150 watts and you still work them. But if you're a CW EMEer, it's more of an issue for you at that. It's good news for less than 150 watt stations on EME because there's no elevation restrictions. CW stations will struggle to work some of the small D expeditions, and small dish Digimod stations will struggle to be seen by other small dish stations. And single Yagi operation, while possible, is going to be limited to single Yagis and some of the mega stations. But there are some positives. I think it's an opportunity to force us to improve our systems. And that's never a bad thing. And we, as Barry said, we're radio amateurs, we like that sort of thing. It could drive the development in terrestrial digimodes. I mean, digimodes on 23 SEMs are antediluvial at the moment because it's mainly FT8. There are some far better modes around now that can be used, and there are more that can be used that are not just single station modes. So I think I need to start a campaign to kill off FT8 on 23 SEMs because it really doesn't work very well. And there's some much better modes. Okay, so that's one of the things it'll possibly do. And it'll, people are going to hate this. It'll level the playing field in contests. It's not just go out and buy a big amplifier and win. So that's it really. I hope that's given you some idea of what my thoughts are. If you've got more to think about, that's the URL to the last position paper. If it's wrong, Barry will update it, I'm sure. I keep banging on about all this stuff in my column, so please read that. And I'm around on the place that used to be called Twitter. So thank you.
Okay, thanks very much, John. Time is marching on relentless, and we'll still have another session to do. Quite happy to take one or two short questions.
Yeah, it's just a comment. You concentrate on the transmit side. The move to 1298 to 1300, of course, comes up against the problem if you're using a transverter and a 2 meter drive that only does 144 to 146.
Yes.
That's going to upset a few people, I think.
Yes, I had heard. Yes, you're absolutely right. I missed that point completely. Thank you, Sam. Yeah. But this just sort of stresses the point that everybody's got to change if we move up there. But it's a decision that has to be made. I mean, I think a lot of 2 meter rigs, modern ones, will extend above that, won't they? I think. But
think it's a major problem, but it is
yeah.
going to be a problem
Yeah.
for some people.
Yeah, I agree.
Okay, in our third section, we're looking at the future of amateur televisions in 23 SEMs, and we welcome Dave Crump to make his presentation.
Okay, good afternoon all. First of all, I'd like to thank Barry for fighting our corner. Having spent many hours in conference rooms in Brussels, I wouldn't envy him his job now. Let's have a look at what we're currently using on the ATV band. We've got in-band repeaters, but all the outputs are up above 1300, so out of scope. We are very lucky. Let's keep it, please. Inputs, though, they're all over the place. And the reason they're all over the place is radars, trying to avoid the radars. So 1248, 1249, 1275, 1280, to try and avoid the radars. These are the NOV inputs. Now, a lot of these repeaters have other inputs as well, but those are the primary inputs. DATV simplex, we're down 1249, 1255, most people. I have actually operated around 1275, but we've got quite a bit of freedom there. So that's what we're doing currently. The transmissions there are mainly digital. Inputs, 333 kilosymbols, that takes up about half a meg, or 1 megasymbols. The older repeaters, some have 4 megasymbol inputs, so that's about 5 megs wide. But the newer repeaters, our recommendation is now they should be 1 megasymbol or lower. The latest one to come on is at 500 kilosymbols, so they're quite narrow. So on the spectrum, that's a 100 meg span. It's actually 100 meg span on 5.6 gigs, but it's the same picture. It looks fairly sharp and spiky, so we're not taking up much room there. But we used to use FM, of course, and there's still some residual FM transmissions around. And new to market, we've got the IC905, which is 20 years late to market, but pushing it. Just as we're about to ban FM. Now, in the same 100 meg span, that's what an IC, this is actually a real spectrum out of an IC905. These subcarriers here, 6 megs apart, that's the sound. So we're looking at 13 megs wide there for the IC905 if you must. So I contend that is not a player for 23.7s, and that's one of the narrower FM transmissions. We talked a lot about power levels. Power levels for ATV are challenging because we need very linear amplifiers, otherwise you get shoulders and you get spectral regrowth out the side. So I think the 150 watt power limit, if that applies to our bit of the band, isn't going to be a problem. I think we might have a lower power limit there, and that's cool. We need to watch that. One of the things we're going to need to watch, though, is if we have something that is actually out of band, the shoulders need to be very low. You know, I don't think people get upset about shoulders that are at a reasonable level within band, as long as they're not interfering with anybody. But if we're sat at the edge of the band, we need to push those shoulders out. When you look at shoulders, this is what we're talking about. The centre bit that carries the information is there, but the shoulders are this bit here. I got this picture by just over driving a driver amp. That comes up to about 30-35 dB there. As you drive a PA harder, you can get them up to 20 dB quite easily. So that's one thing we need to watch. In considering where we can put DATV in the new shape of band, we need to watch for radar interference. 1248, 1249, 1255, it depends on where you are in the country, where the radar interference is. But we've got some really good techniques now we can get good high definition pictures using H.265 encoding in a 333 kilosymbols signal, which easily fits within 500 kilohertz. Even 125 kilosymbols gives a good standard definition picture that looks a hell of a lot better than any FM picture that people have done in the past. So, and that could be considered narrowband transmission. You know, if you use old SDRs, about 190 kilohertz wide, if you set the roll-off to 0.2 with modern software, you're down to 150 kilohertz. And then we're into Barry's definition of narrowband. So looking at places where we might go, I've taken as an example here the French proposal. I accept it may not go that way, but to show you the sort of things we could do. Could we take a repeater input down right at the bottom end of the band to avoid some radars? We'd probably put it at 1240.75 so the shoulder doesn't fall in somebody else's band. Could we put another repeater input right at the top end of the acceptable range if we've got a radar down at the bottom end of the range? You know, avoiding the radars. Simplex channels anywhere in that area, but probably a primary around 1240, 1255-ish. Up here, remember we've got a narrowband restriction here, probably, but we've got the high power level available. How about we put a simplex channel right up at the top of the 23 cent band? John said, you know, it's not used very much for voice and stuff. Let's chuck something up there, perhaps a 125 kilosymbol channel. And that way you can take your SDR and you just replace your 144 megs or 437 meg driver on your transverter with the output of your software-defined radio, and you use your narrowband kit to do TV there. So it's not as bad as it might seem for TV, I think. In choosing where we go based on the final solution we get, we've got to look at spectral regrowth, make sure we're not making things difficult for people by putting things out of band. We've got to avoid the radars. Anybody know where that one is? Absolutely, yeah. It's it. That was Heathrow one, which of course has gone now. 1 to 5 kilosymbols, or perhaps we could take it down to 100 if we need to, isn't wideband. And if we can go get a slot at the top of the band there, I think that would be very useful for ATV activity. So digital ATV gives us this flexibility. Don't forget, it also improves your link budget. You know, you're talking about a 16 meg bandwidth for an FM TV signal. Wind that down to 333 kilosymbols. That's 32, which makes 14 dBs. Really good on the link budget, and the picture quality is better. The downside is delay. 2 to 3 seconds, 4 seconds of delay. But it's not a digital mode, you're still talking to people. And with that, I'll take questions. Thank you.
Okay, we're actually just about out of time, so if anyone wants a couple of short questions, if you don't mind. Any takers? Obviously, you've done it well, you've put it over very well.
Thank you very much.
Thank you very much, Dave. Could I ask you to show your appreciation for all three speakers? It's been a very entertaining session.